everyone, welcome back. This is Calculus 3. In this video, we are going to talk about 1.4, area under arc length in polar coordinate system. So a little bit of, review from Calculus 2. So in Calculus 2, we've been dealing with X, Y, rectangular coordinate system. So the definite integral provides a way to calculate the area under the curve. For example, if you have a function y equal to f of x, and I want to find out the area under the curve between a and b, by using the integral, we were able to find out the area under the function f of x, right? Also, you were able to find out the length, which is a curve. This is not the linear. There's an arc length formula. So if you have a specific interval and then 1 plus f of x prime, you're going to take the derivative in second power. So there are particular formulas to find out the area under the function and the arc lengths in Calculus 2. What we are going to do in Calculus 3, we've been dealing with a very unique function, rectangular coordinate system, and also polar coordinate system, correct? So what if your function, instead of regular linear quadratic polynomial, what if we have a polar coordinate equation? Polar equation, how would you be able to find out the area under the polar equation and the length polar curve, right? So that's the main idea. What we're going to do in 1.4, we are going to find out the area and arc length in the polar coordinate, especially polar equation. Okay, so let's take a look at the more specific information. I'm going to go down slowly. So in general, we know how to find out the circle. So let's say you have a circle. Let's say you have a polar equation as a circle function. Okay, so let's say this is your polar equation, and I want to find out the particular area from the radius is r and the angle is a theta. I want to find out this area. You see that? So I'm going to change the color. I want to find out this piece. I want to find out this sector of this polar equation. Yeah. So in general, if you remember, so there are a lot of previous concept that you learn in trigonometry. So we have a circle and there's a radius. So we want to find out the area of the sector in polar equation. So basically I want to find out this piece of area, this area. And then the area of a sector, we know you have a pi r squared. This is the entire area, pi r squared. This is a circle area, but I'm not looking for the entire circle area. I'm looking for only this piece, which is a theta divided by 2 pi. So this is the entire circle area times a piece, the sector that we are looking for. So this theta is this part out of the whole. So this is the part out of whole. You can think about it. So 2 pi is 360. Theta is the sector that we are looking for. So if you have a pi r squared times theta over 2 pi, that's the general formula to find out the area of the sector, correct? And then I'm going to simplify these two equations. Pi going to be canceled. So we have 1 over 2 r second theta. So this is going to be the formula to find out this sector. And then we are going to use the integral because this is the area. And then you're going to take the integral, whatever the given angle from A to B, and then you're going to take the integral. That's the area of the polar coordinate system. Does it make sense to you? So you don't need to memorize this proof that I show you. Just think about it, where this formula. So actually this formula is developed to this way. So we are looking for the area of the sector, right? So 1/2 times r second power times the theta. So in terms of the integral, r is going to be your polar equation that is given. So whatever the polar equation second power, take the integral with respect to theta. That's the formula to find out the area of the sector. Does it make sense? So that's why we are going to utilize this formula to solve the following example. I just wanted to share how and how this formula came from. So we are looking for the area of the polar equation. Specifically, if I want to find out this sector, so this is a 2 pi r squared times theta over 2 pi. So we found out this one. We are simply taking the integral. So you're going to use this formula to find out area of sector in polar equation. Does it make sense? So let's take a look at the following example. So we're going to look at the question. Find the area bounded by the polar curve. So this is the polar equation. We don't know what does it look like, but they say it's going to be curved. And then they want to find out the area between 0 to theta. So between 0 to pi. So they want to find out like this area. Okay. So we don't know exactly what the shape look like. That doesn't matter because we know how to find out the area by using this formula. So our function, the polar, this is a polar equation is a given, right? And then we are looking for the area. So I'm gonna write it. So the sector area we are looking for is 1/2 according to the formula. And they say from 0 to pi, that's the sector that you're looking for. So 0 to pi. And then formula said, this is r, so sine theta plus cosine theta. You are going to square of it and take the integral with respect to the theta. That's it. That's how you're gonna set it up, set up the equation, and we're gonna solve the rest of equation. I'm going to, let's expand sine theta times, plus cosine theta. So 1/2, 0 to pi. So that means sine theta plus cosine theta. Sine theta plus cosine theta. So I'm going to expand by using the FOIL. So that would be 1/2, 0 to pi, sine second theta, and we have a sine theta, cosine theta, and then there is cosine theta, sine theta, cosine second theta, d theta. Ooh, what do you guys see? Do you see that? Sine second theta plus cosine second theta, they're going to be 1. And then these are, you can combining like term. So this is going to be 1/2, 0 to pi, and I have a 1 plus 2 sine theta cosine theta, because you have the same thing too. I'm gonna minimize it. So I'm gonna bring this one, it's pi. So we are going to take the integral. Are you following? So let me separate them. So it is going to be 1/2, 0 to pi, 1. And then I'm gonna make a big bracket. So integral 0 to pi, 1 d theta, 0 to pi, 2 sine theta, cosine theta, d theta. We are okay? So now we can take the integral. So what are you guys gonna do? So the first term, if you take the integral, that is gonna be theta. Am I correct? So that is going to be the theta. So this is going to be theta. from 0 to pi. And then 2 is a constant, correct? So we have a 2 to the front. I have a sine theta, cosine theta, d theta. Are you following? And now think about it. This is very, very, very similar work that you did in calculus 2. We're going to use u substitution. So according to the u substitution, I'm going to say let u sine theta. So you're going to take the u substitution method, take the derivative with respect to theta. So sine theta will be cosine theta. So we're going to do the cross multiplication. D theta is a cosine theta times du. Or actually I made a small mistake. Du, right? Cross multiplication. Du is equal to cosine theta times d theta. So what does it mean? Cosine theta, d theta, that is going to be du. And then since we change every theta in terms of the u variable, we're going to change the interval in terms of u. So if you think about it, I'm going to minimize it a little bit. So here we have 0, pi. We're going to change it to the new interval in terms of u. So u0, you're going to plug in into u substitution. Sine 0 is a 0. u1, actually u pi, if you have a pi, sine pi is going to be also 0. So what does it mean? The 0, pi, in terms of the data, they're going to be 0 and 0. This is a u variable. So let me write it everything. So this one, 1 over 2, and you can work on this part. This means capital pi minus 0, so which is pi minus 0. You should get just pi. So this is going to be pi. So we have a pi, and I have plus 2. We have a 0 to 0. Am I correct? And then we have a sine is a u, and then cosine times the d theta, that is a du. But wait. You have to be careful. Is there any area from 0 to 0? There's no area. So the interval is not, there's no space, there's no area from 0 to 0. So even though you're taking the integral, this part is going to be anyway 0, because the interval is from 0 to 0. There's no area. So we have only 1 over 2 times a pi. So pi over 2, this is the area that we are looking for from 0 to pi of this polar equation. Like this is a sector area of this polar equation from 0 to pi. Why do I say, why am I saying this is a sector area? Because we are covering only from 0 to pi. So that's your answer to find out the area of the polar equation. It's not that complicated though, right? Because we have a very similar work, in calculus 2, because integral help us to find out the area, volume, arc length, so many, physical concept area. So you can do the similar work here by using the polar equation. Just function is going to be changed. Okay, so depending on the function, you're using a different technique. So this is the area of the polar equation. So I'm gonna keep on going because the polar equation is very unique. So if you guys watched the video in the last time, polar equation has a very unique pattern. If you remember, such as a, rose pattern, or what is it? The heart-shaped pattern. So depending on the R function, you can find out very, a variety of a graph of the polar curve. So let's take a look at the following example. Ooh, so exactly, this is the rose shape of the, I'm gonna write a rose shape of polar function. So exactly, this is a particular polar function, polar equation that shows you the rose shape when you graph it. So they want you to find out the area. One of the paddle, right? From where? 0 to 90 degrees. So they're looking for exactly this area. they're looking for this area 0 to pi over 2, right? So if you remember Rosa shape, this is from the polar, Rosa shape of polar equation. So the function was r equal to a times the sine b theta, r equal to a times cosine b theta. So if b is even number, you have the same petal. If b is an even number, you have a double petal of the rows, right? So b petal, same number, and double petal if it is even. So anyway, exactly we have Rosa shape of the polar equation. Okay, we are looking for that yellow area. Am I correct? So let's take a look at the formula. We know how to find. This is exactly sector area of polar equation, one petal. So therefore, sector area is 1 over 2, the formula from 0 to pi over 2. And then we are going to square of that polar equation and take the integral with respect to theta. That's it. Okay, so let's expand it. So 1 over 2, we have a 0, pi over 2, 16 sine second to theta d theta. Are we okay? And then here, I'm going to make a little bit of note in the bottom. Okay, to solve this question, we should know the following identity that you learn in trigonometry. So let me go down a little bit here. So here, double angle identity. Did you remember from trigonometry in calculus 2? So number 1, sine 2 theta, double angle, you can rewrite it 2 sine theta times a cosine theta. Number 2, if you have a cosine double angle theta, you can reduce down 2 cosine second theta minus 1. Or there's a couple corresponding to cosine 2 theta also equal to 1 minus 2 sine second theta. And then same thing, one more, cosine second theta minus the sine second theta. They're all correspond. And then third, sine, if you have a second power, I want to reduce down the exponent, 1 over 2, 1 minus cosine 2 theta. And then last one, if you have a cosine second theta, you can reduce down the exponent, make it equal to each other, 1 over 2, 1 plus cosine 2 theta. So these are the double angle identity you actually learn in calculus 2, because this is very necessary thing. Whenever you see the double angle, whenever you see the double exponent, we can reduce them. So let's take a look at it. This guy is bugging me. Sine second to theta. This is a second power, and there is a double, right? So what are you guys gonna do? We can convert it to with this one. So this is a 1 over 2, 0 to pi over 2, 16 stay there. And then actually I'm gonna bring 16 to the front. Let's do that. So times the 16. 0 to pi over 2, we have a sine second to theta, right? So this is equal to, what do you guys think? This one, 1 over 2, 1 minus cosine, and then you have a 2 theta, you're gonna make it double. You're gonna make it double, so 4 theta. Are you following? And then we are taking the integral. So that's something you need to convert. Yay. And then let's simplify. So what happened? They're cancel 8. I'm going to bring 1 over 2 to the front. So 1 over 2, 0 pi over 2, 1 minus, right? Cosine 4 theta and d theta. All right, nice job. And then I'm going to simplify 4. And let's take the integral. So you're gonna separate it, pi, 0 pi to 1 d theta minus 0 pi over 2 cosine 4 theta. Are we okay? Yes. And keep going. I'm gonna keep simplifying. Let's take the integral. So 4, this is going to be theta from 0 to pi over 2 minus, and be careful. Do you remember how to take the integral cosine for theta? You are going to, so let me write it, note. If you take the integral or nx, whatever, it is going to be flip n, and then it's going to be sine. You keep n theta, right? So that's how you are going to, so there's no more integral, my bad. So it is going to be sine n theta, correct? So keep using this. So this is going to be 1 over 4 flip, and then sine, keep 4 theta from 0 to pi over 2. Boom, 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 we got it. So this is going to be equal. Yeah? And then we are going to simplify. So 4, what happened? Pi over 2 minus 0, right? And then second one, we have a 1 over 4 sine. So 4 times a pi over 2 minus, oh, I need a space. 1 over 4 sine. And then this is going to be 0, because 4 times 0 is a 0. And then we are going to subtract them. Are you following? So this is going to be this, that. You have to subtract f capital pi over 2 minus f 0. So this is going to be 4 pi over 2. And then this is 1 over 4 sine 2 pi minus 1 over sine 0 is a 0. So that's going to be 0. Sine 2 pi, what do you guys think? It's a 0. Every 2 pi, 4 pi, 6 pi, it's a 0. So they're all 0. So we have a 4 times a pi over 2. Gotcha. 2 pi is the area of the one petal of this rose. Does it make sense? So the concept, it's a pretty understandable. It's not complicated at all. The formula is a given. You just need to define where's the area of the polar equation. And then calculus is just your practice. Take a look at all the identity if you need, and then you can find out the area. Awesome, awesome, awesome. I hope you guys are smiling, right? All right, so we're gonna keep practicing like that. Let's take a look at one more example. All right, example 3, okay. Now this is a cardioid shape. Do you remember? This is also part of the polar equation. Do you remember? R equal to 1 minus the sine theta. They have a heart shape. They're looking for the area from 0 to 2 pi. So basically they're looking for all this area. Yeah. So we can find out the area, sector area, 1 over 2, 0 to 2 pi, 1 minus the sine theta, second power, power d theta. I'm going to expand it. So 1 minus 2 sine theta plus sine second theta and d theta. Gotcha. Again, I'm going to separate them, but you can simplify. What do you guys think? This is a double exponent, so sine second theta, you can change it to here, here, here. Sine second theta, you can convert it to this one. So I'm going to convert it that. So it is going to be 1 over 2, 0 to 2 pi, 1 minus 2 sine theta. So let me just theta. And this is equal to what? What do you guys think? 1 over 2, if we go up, there's identity cosine 2 theta. And then we are going to now take the integral. All right, so that's the same. We convert it. double angle identity, double exponent identity, we reduce down. So now I can expand it at 1 over 2 from 0 to 2 pi. 1 minus 2 sine theta, I can distribute property plus 1 over 2, 1 over 2 cosine 2 theta d theta. Oopsie, sorry. So let me make a space under here. So now you can combining those two. So 1 over 2, 0, 2 pi, 1 plus 1 over 2, that's a 3 over 2. Minus 2 sine theta minus 1 over 2 cosine 2 theta. One more time, this is a double angle identity, right? But I can just leave it at, that's fine. So we can have cosine 2 theta. We cannot convert right now because we're going to take the integral. So now you're going to take the integral. What happened? This guy is going to be 3 over 2 theta. 2, if you take the integral of sine theta, that is going to be negative cosine theta. Are you following? And 1 over 2 here, this is the thing. Do you remember? If you take the, I'm going to make a note. If you take the cosine n theta integral, it's going to be what? Sine, you're going to flip over n over 1 over n. Then it is going to be sine n theta. So we are going to have sine. We flipped. We actually have to flip. So this is going to be 1 over 2 flipped. Sine, same thing to theta. Got it. So we finished the integral. So now simplify as much as you can. So 1 over 2, 3 over 2. Actually, we have a from 0 to 2 pi. Theta, I'm going to double negative, change to positive, positive to cosine theta. And then it's going to be 1 over 4. And I have a sine 2 theta. That's it. And now we are going to subtract 2 pi minus 0. So plugging in, we have a 1 over 2, 3 over 2, 2 pi, 2 times cosine 2 pi minus 1 over 4 sine. 2 times 2 pi will be 4 pi. So that's the minus. We have to all the 0 part. So minus 1 over 2, all 0. So this is going to be 0, 0, 1 over 4. Actually, my bad. So 3 over 2 times 0 is a 0. And 2 times cosine 0 minus 1 over 4 sine 2 theta. So theta is a 0. So it's going to be 0. All right, that's a better. So 1 over 2, 6 pi over 2, cosine 2 pi. What do you guys think? It is 1. So if you remember cosine, every 2 pi, you're coming back to 1. So 2 times 1. Every 2 pi, 4 pi, that is also 0. And then what are you guys going to get? The next one, minus 1 over 2. This is a 0. Cosine 0 is a 1. And then this is going to be 0. So 1 over 4 times 0 is a 0 because it's a 0. So I'm going to simplify again. 1 over 2, 3 pi plus 2. And then this is 1 over 2 times 2. So if you simplify really, that is going to be, I'm going to distribute a property 3 pi over 2 plus 1. This is 1. Ooh, plus minus bye-bye. 3 pi over 2, approximately 4.71. That's the area of the sector of this cardio shape from 0 to 2 pi. We got it. How you feel? You like it? I like it too. Very understandable topic, more mathematical expression and calculation stuff, but the concept is pretty okay. All right, so I think this one should be okay. So far we practiced 3 examples. Now I'm gonna do a little bit of challenging question. Are you ready, ready? So let's go. Example 4. So a little bit of background. So in calculus 2, do you remember? let's say you have a one function, and then you're looking for this area between A and B. Everybody know this is gonna be, you're gonna take the integral of the f function. But what if I have two functions? I have f, and let's say I have another function, g function. We're looking for the area between f and g. Do you guys remember how to do it? It's the same thing in this time. So let's say this is A and B. So A and B, you have a large height function minus the lower height function. If you subtract, you can find out the area between two functions, right? So that's the background. You're already learning calculus 2. So we're gonna do the same thing. Here, I'm gonna give you guys two polar function, okay? And they're looking for the between area, okay? In this time, they didn't give you what the A and B. So we have to find out the intersected point between two polar function, and then you can take the integral. Does it make sense to you? So let's take a look at the area, the question more. Find the area inside of the polar function when it, r equal to 4 times the cosine theta. So this one is going to be r equal to 4 times the cosine theta, and outside, which is the radius is a 2, this is the 4. So the radius is 2, I'm going to use a green. So this one is a radius 2. So this is just, we have, this equation is very simple, r equal to 2. They just said that, r equal to 2. So we have two functions. One is r equal to 4 times cosine theta. Another one is r equal to 2. They are looking for the area where inside of the purple, outside of the green. So where is that area? This is the area they're looking for. Inside of the purple, outside of the green. So that sector we are looking for. And then they didn't give you exactly where is the intersected point, because that's your A and B. That's your the angle between two functions. So to find out the intersected point, so we know how to do it, make those two equations equal to each other. So to find intersected point between two functions for cosine theta equal to 2, because both of them are r. Now, I'm going to divide it by 4. So cosine theta, 4 cancel, is a 1 over 2. That's a 2 over 4. So what is a theta? Is a cosine inverse 1 over 2. You can simply use a calculator or go to the trigonometry table that I showed you in the last time. The theta is going to be plus minus pi over 3. So one angle, this is going to be minus pi over 3. This is a positive pi over 3. Okay, so one is positive 60, another one is negative 60. So that's where you're looking for. That's your angle. So we have all the information, isn't it? Now we are looking for the area. So sector area from the formula is a 1 over 2. Now from negative pi over 3 to positive pi over 3, where is the function? We have to subtract where? To where? We're going to subtract the large function minus a smaller function. So here, just a little bit of thing. The formula set we have, if you go up, we square of it. So don't forget the square. So therefore here, it is going to be the first function square minus second function d theta. This is the between sector area, the area between two functions. So we are using this formula. Am I correct? So you can discover this information. Are we okay with that? So we're gonna say f is gonna be 4 cosine theta, and g is going to be 2. So let's plugging in everywhere. One more time. 1/2 negative pi over 3 positive pi over 3. You're gonna square of it, right? So that is going to be 16 cosine second theta minus 4 d theta. Are we okay? Yes. So you got this one. Okay. So now what are you guys gonna do? We're gonna take the integral. So let's take a look at it. 1/2 minus pi over 3 positive pi over 3, 16. Ooh. What happened? This is double. I can reduce now. This is going to be, if you simplify, 1/2 times 1 plus cosine 2 theta. They are same. And minus 4. Right? And then we are going to take the integral. So keep going. So 1/2 minus pi over 3 pi over 3. So they're going to be 8. 8, 1 plus cosine 2 theta minus 4 d theta. So 1/2, I'm going to expand 8. So 8 plus 8 times cosine 2 theta minus 4 d theta. So 8 minus 4, we can subtract to each other. So 1/2 minus pi over 3. And then 4 minus 4 is 8 minus 4 is 4. And 8 cosine 2 theta d theta. Let's take the integral finally. So 1/2, I'm going to make a little bit smaller. So we have, this is going to be 4 theta, 8, and then cosine 2 theta, right? If you take the integral cosine and theta, we're going to flip the constant in sine and theta. So this is, you're going to flip 1/2 to become 1/2 sine 2 theta. And then from negative pi over 3 to pi over 3. All right, so we can simplify one more time. Cancel 4 sine 2 theta from negative pi over 3, pi over 3. Now I can multiply 1/2, right? So if you do that work, what are you going to get? So it is going to be 2 theta, and then 2 sine 2 theta from minus pi over 3 and positive pi over 3. Are we okay with that? Yeah, so we got this one. And now let's plugging in pi over 3. So 2, because we have to pi over 3 minus negative pi over 3. So 2 times positive pi over 3 plus 2 sine 2 pi over 3, because 2 times pi over 3. This is minus the next one, 2 times negative pi over 3. 2 times the sine negative 2 pi over 3. I know this calculation is a little bit ugly, right? So you can simplify by using the decimal. If you just enter those complicate function into the decimal, but we can simplify as much as you can. So this is a 2 pi over 3. 2 sine 2 pi over 3. And then, you can plugging in. So just change everything. I'm going to actually stop here because you can just enter. Just go to decimal, type all this expression. I actually already calculate for you. It is going to be approximately 7.65. Check it out. Okay? Because this is not, we can do mentally, right? You can use a calculator, evaluate what the sine 2 pi over 3, evaluate what the sine negative 2 pi over 3. So you are going to subtract from here to here. Using decimal, it's okay. They are going to be calculate it for you. So it's going to be about 7.65. Okay, so that's the area, the purple area we just got. Okay, so this is the area where you are dealing with two polar function, and the formula is right there. We just discovered, right? This is the, oh, I don't like this color, so let me use yellow, right? This is very, so the square, the first function minus the second function square, you can find out the between two functions, the sector area. We got it, okay? So I'm pretty sure you can do this work. All right, so I think I'm gonna skip this one. It's the same question, try. So this is the between two polar curve. You're gonna find out the area. You know, one is outside, one is inside. Just read the question. I didn't give you the A and B. You're gonna find out the intersected point first, and then inside, and then you're gonna find out the outside. So check it out, okay? So you can find out the area. Try this one. It's the same question like example 4. All right, last concept, 1.4. I'm gonna move on. So I told you, arc length is also, so if I go all the way up, if you remember at the beginning, in calculus 2, you also learn how to find out the arc length. This is the formula, but we are dealing with the polar equation, right? So the formula is actually given right there, okay? To find out the arc length of a polar equation, correct? That is going to be, you have a same A to B, whatever the given, interval, r second plus, you're gonna take the derivative of the r function and square of it, take the radical and integral. That's it. So this is the formula. You're gonna very similar you learn in calculus 2. So it's not really proof stuff. We just follow the formula to find out the arc length. So in this time, we're gonna find out the polar curve length, right? Because it's not gonna be the linear, right? So according to this formula, let's look at this question. So polar curve length equal to, they have 0 to pi over 2, correct? And then the function is given, r equal to theta second power. So according to, you're gonna second power, theta second to the second power plus, you're gonna take the integral. So r equal to theta second. So what is r prime? So that means dr over d theta. It is going to be 2 theta. So you have a 2 theta, second power, and d theta. That's how you set up the equation. One more time, this is r squared. This is what? F dr over d theta square. You're gonna take the derivative first and square of it. Awesome job. So now we just do the work. That's it. So if I simplify everything, so this is 0 pi over 2, that would be theta to the 4, correct? And then 4 theta to the second d theta. I'm going to factor out here because the second theta second power, it's a common factor, 4 d theta. That's a separated. So this is a theta second and theta second plus 4. We can break them into two, terms because the second theta radical, they are going to be simplified, cancel. So that is going to be theta. We have theta second plus 4 theta d theta. It's okay. Don't be stuck in here. We know how to do this work. It is the same stuff we did, u substitution. So you're gonna let u, because this inside has been sub into the radical function. So there's a 2 structure. One is a radical function, and then quadratic function has been sub. So we're gonna use a u substitution, u equal to theta second plus 4 theta has been sub. So you're gonna take the derivative u equation in terms of the theta. So it's going to be 2 theta plus 4. My bad, there was no theta. Why did I have a theta? There's no theta, so there's just 0, right? So theta squared plus 4, you're gonna take the derivative. So 2 theta remaining. So that means what? Cross multiplication du is a 2 theta times d theta. I want to find out this one, theta times d theta. So if you divide it by here 2, you will get du over 2 cancel theta times d theta. So exactly theta times d theta can be replaced by du over 2. Does it make sense to you? That's a skill. Excuse me, when you're taking the u substitution. So therefore, this one, 0 to pi over 2, u, right? And then theta times d theta is 1 over 2 du, which is here. And then you need to also change the interval in terms of the u. This is in terms of theta. So therefore, we're going to convert, we're going to change the interval. So that's the work we need to do. So I'm going to bring here. So pi over, actually 0 to pi over 2, we are going to convert in terms of u. So u 0 is going to be 0 squared plus 4 will be 4. U pi over 2, you will get pi over 2 second power plus 4. Oh, pi second power 4 plus 4. Am I correct? So we got it. This is 4 to pi second over 4 plus 4. That's a new interval. Okay. So let me bring, let me bring this one here. So now we have all the information. From 4 to pi second over 4 plus 4. So you're going to take the integral of this expression. So then it's going to be, what do you guys think? This is the same as u to the half exponent. So we can bring 1 over 2 to the front, or pi second over 4 plus 4, and radical u du. So this is a half exponent, so I can change it this one, u to the 1 over 2. So 1 over 2, u 1 over 2 plus 1. You're taking the integral divided by that summation. You're going to divide it by the summation from 4 to pi second over 4 plus 4. Almost in there. So what are you going to do? We can flip this one. Oops, my bad. We can flip this up. So that means 1 over 2 times 3 over 2 become 2 over 3, because that was in the denominator. I'm bringing it up. And now u 3 over 2 from 4 in that. Are you following? So now we're going to simplify. They're cancel. So we have a 1 over 2, sorry, 1 over 3 now. U to the 3 over 2, you're going to subtract from the top to bottom. All right, almost done. So you're going to plugging in 1 over 3, pi second over 4 plus 4, 3 over 2 minus 1 over 3, 4, 3 over 2. Are you following? This is a red large up minus the bottom. Again, we cannot do this one mentally. You're going to put into the decimal and calculate. I haven't calculated yet, so you can try. So if you use a decimal, it's going to be very, very simple answer. You can get a decimal. Try this. Okay, so you're going to just enter this equation. They will calculate it for you. So that's how you're going to find out the arc length of the polar curve of the polar function. Okay, so this is the formula. I literally use the same thing. So it's a similar work we did in calculus 2. So you should be able to solve all the question in 1.4. It's only 2 simple goals. Find out the area and arc length of a polar equation. Okay, so there's one more example. You can try that. I will just set up the equation for you. So what happened? We are looking for the length. This is a polar equation because r and theta. So therefore, the polar curve length, and they say from 0 to pi over 2, you have radical 2 plus 2 cosine theta. This is r squared, and you have to take the integral, right? So this is 2 plus 2 cosine theta. What is r prime? This is a 0. And then 2, if you take the derivative of the cosine, what is it? Right? Derivative cosine is a sine, but is it positive or negative? Anybody remember? It is going to be negative, so it's going to be negative sine theta. So you have negative 2 sine theta. That's r prime. So we have negative sine theta second power. Are we okay with that? So that's it. That's your formula, and you're going to calculate the rest of things. So this is r second. This is dr over d theta, and then second power. So I'm not going to do the rest of work. Try the rest of work. Same thing. We just did it above. Okay. So 1.4, it's a pretty short topic. We talk about how to find out the area and arc length of the polar equation, so that now you can just think about, it's a very similar from calculus 2. Okay. So I try to solve as many as I can so you can have a better understanding. So if you're ready, go to 1.4 quiz, and there are more video you can watch. Feel free to post in our chapter discussion if you have any question, or email me as well. Okay, have a great day, guys. I will see you guys in the next video. Bye-bye.